In this episode of FUM0157 machining, we are going to deal with stepper motors. Well, first of all, how to identify one, how to drive one, and we are going to do some testing with my equipment here, doing some demonstrations. I have a lot of different types of stepper motors and therefore, well, hopefully this video doesn't become too long because this is a subject I really love and therefore I might be talking too much. Hopefully not. So let's start with how to identify one stepper motor. So here is a box filled with well, stuff. And well, let's see if we can find some stepper motors here. So this bag, this I already know, it's filled with solenoids. Well, we don't need those today. Well, then we have this guy here. This doesn't look like a stepper motor because first of all it doesn't have any magnets. It rotates freely, and if you read on the label, oh, well, it's induction motor. You can read on the label, not a stepper motor. So not this one. Okay. Then what's this guy? This is, oh, superior electric synchronous stepping motor. Okay, this is a stepping motor. We could probably try this out if we can. Okay. Then what's this guy? Thermally protected oriental motor. Reaction motor, well, induction motor in plain language. It's just a three-phase motor. Okay, we don't need that. Okay, that one we need. Then let's go on. Who is this guy? I actually know who this is, and this one is really. This is a three-phase motor, but it has been driving a tape recorder. We don't touch that one today. Well, another induction motor. There is a good looking candidate. Well, it has a gear on it. Do I have a duplicate? Yes, I do. Okay, here we have one that has. I have cut the shaft. Here is one, okay. This is definitely a stepper motor. You probably can Berger Lar, it doesn't say anything in the label. W Germany, a German made stepper motor. Well, you probably can tell that this is a stepper motor when you try to rotate the shaft and you can feel steps there. Okay, this one we will try out. It's probably a stepper motor. Then we have this guy. And stepping motor. You can read in the label. It is a stepping motor, and and this one you can feel the steps. It's very good. Furthermore, do we have some other types here? That one we already have. That one we have. Well, here we have one that's also a stepper motor. Should we try this out? No. Let's see something that is not a stepper motor. It looks like one. Well, this doesn't. This tells that this is Lenko. Well, it's actually a synchronous motor. You put this AC in and it will rotate. Well, not a stepper motor. Then we have that guy. And this, although it doesn't look like a stepper motor, Kinex it says, this actually is a stepper motor. It just doesn't have that many steps. We could try this out. Furthermore, any more? Well, let's see if we have something in this box. Oh yeah, so here we have some really good candidates. Well, first of all, I can tell this is not a stepper motor. You can actually, it's just an ordinary motor. And then we have, this is really nice. It has 1.8 degrees per step, so quite tight stepping, and you can feel it. Oh yeah, we will figure out what's this one. And then let's go even smaller. If we find one, here we have one that's really small, and I know this is also a stepper motor. So yeah, we will try this one as well. Anything more? Well, we would have a lot of them, but let's see if we can. Let's put this together so I don't lose the motors. They are really small and okay. There you go. Well, we also have these guys. These are actually stepper motors, but here you can feel the steps. That's 1, 2, 3, 4. 4 steps for a revolution. These are intended, they have some internal electronics here. Not a lot, just hall sensors, so they know in which position this one is. And these require special driver to run them. And these are really, these can run like super fast. Oh, we have one stepper motor which is, well, looks nice. Let's try that one too. So, that enough stepper motors? Well, I believe we are good to go with those. So, let's go to the workbench with these. So, here is the workbench, and now we have the different motors here. These are all actually stepper motors. Different types and different connection types, etc. So what we need to do when you see a stepper motor and for example you scavenge it from some equipment. For example, this one has originates from a printer, and it's still in a very tight, good condition, and this one has the benefit of having all the details in the label. So, well, you can see that it's with the type number. You can Google this one, and then you get the details. And well, it has a lot of wires coming out. This might be a problem, but we go into that, how to identify these wires and what they are, etc. And then we have these kind of guys which have not so many wires. This has only 5. What's this? And then we have this which only has 4. Well, and even less. This one has only 3. Well, that's quite a low number of wires. This has 6. And I know this big one, this big guy has 3. So, how to start this identification operation? Well, I will first unbox this one. That's well, a package which I received from eBay. I bought from eBay, and this is well, Stepper Online. It's a stepper driver, and this one should contain some sort of documentation which explains some of this stuff. So let's put these motors aside for a moment. Okay, now we have this box. Well, it says, please save this label. Why? Why on earth? Well, let's see, it's very well taped. I think if we put our knife in there, but maybe we can... Okay, now I got it. Yep. Okay, we have a manual here. Okay. User manual, Benutzer Handbuch. Aha. User... okay. And what's this? This is the device. And just some things there we don't actually need here. Trash bin. So this is our stepper driver, and let's see what's in this handbook. Oh, here we have it. These are the configurations this thing can handle, and well, I can tell you right away that this device cannot handle the stepper motors with only 3 wires. It's obvious. So with 4, yes. With something like 5, yeah, and 6, yes. You just don't connect all of them. 6 and 8 lead motor. Okay, you have to put them in a certain way. Okay. Well, let's see what's inside here. I'm a little bit interested, and let's see if I can find the correct tool for that one. This, I believe, is... no. This is quite good for that one. Okay. Let's see if we can open it. There is... oh yeah. QA passed. Okay. That's passed. And let's see what we have inside. Okay. Okay, now it comes out. Well, what did I expect to see? Well, oh yeah, it's a very normal thing. Actually, there is somewhere a microcontroller, I believe. Then we have here under, we have the power transistors, all I believe we have 8 of them, as there should be. Then we have, these are current sensing resistors, because this unit needs to limit the current, so it needs to sense the current that is going into the device. Then we have some sort of power supply here, probably it's an isolation thing. So it isolates the logic from the stepper motors, I believe. So then we have here 6 and something. These are optocouplers, which are isolating your input from the rest of the system. Very good. And furthermore, well, just some connectors, a dip switch, which you use to configure the thing. That's pretty much of it. A lot of logic and so on. So, well, just let's put it back together. There is nothing user serviceable here inside. So this is well, it contains electronics. Okay, so it's very nicely labeled actually. If you, I will show you a nearer picture of this. First of all, we have here like the output and power input. Okay, that's yeah. So we have the wires that go, the 4 wires that go to the stepper motors. Then we have the power input, which contains your power supply, goes somewhere there, and then we have here enable thing. Okay, we have a direction thing, and then we have pulse, probably a pulse input. Okay, and all of these look like they have an internal resistor in there. Well, I should have checked that one, but they do, I believe. And then they have a LED. That's the LED of the opto-isolator. I will feed the pulses from a signal generator direction manually directly. Enable, let's see, it has to be activated for this to work. So, let's take our first stepper motor candidate. Let's take a simple one, the one with 4 wires. There you are. There is your motor with 4 wires. Well, it has like half a meter long wires, and they are already like peeled. Okay, let's see. So you just connect 1 to 1. There should be A and B side, and this stepper motor is really easy to figure out because it has separate. You can tell that this one is 1 winding and this one is 1. Not too hard to figure out. So let's put these into, let's say this is the A. So we this is A and this is B, I believe. The order is important, but it will run no matter which way you connect these, as long as you hold the A and B sides separate. It will run, but it might not run in the direction you intend. So if it runs in the wrong direction, you just take one of these and swap the wires, and there you are. Then it's running in the intended direction. We probably need to configure this one 1.1 amps and 3.5 ohms, but these ohms are not 1.1 peak current. We put the lowest, so switch 1, 2 and 3 should be all on. Switch 1, 2, 3 all are on. Ha! That was easy. It's 800 pulses per step. Okay. Okay. That's okay. Well, the next thing we need to is to put some power into it. Well, I have a power supply here on the side. Let's look into the technical specifications. Electrical specifications, output peak current, okay. Input voltage, okay. Minimum is 20 volts. Typically 24 to 36 volt and maximum is 50. So actually I can switch this on and put everything I have here. I have 30 volts. I could connect this on series, so I could get 60 and probably get the smoke out of this, but 30 volts is okay for us. Okay. And where is our plus? Well, you can see plus. Okay, we have plus there. Well, let's. This is our plus wire, goes into there. So this was plus. Okay. Okay, there you are. Let's put it in. Let's see what happens here. So now it's connected, but the current limiter is well. It certainly looks like Well, it's actually it is doing something for the motor. Okay, so it's actually taking at the moment something like 100 milliamps from the power supply, not too much, but it's enabled, because I know, because you cannot turn this. Now if I switch off the power, you can turn this really easily. Okay. Okay, let's put this here like that. That's well. Oh yeah, okay. So enable, high level disables the more. Well, here is a bunch of 1 kilo ohm resistors. Let's switch that one on. And now what we need here is maybe some. I would like to put reverse diodes on these ones in order to protect the. Okay, let's use this. How many do we need? 3. Okay. So I will put these are just normal silicon rectifiers, diodes. Okay, that's the common ground. Common ground goes, this is the negative, goes there. Okay. Now it doesn't want to turn, okay. Then I will put a signal there. I'm using a 1 kilo ohm resistor here in between. At least the current went down, and yeah, this is an enable. Disable. It means that when this is getting a signal, it will let the motor go. Okay, so you normally let this be unconnected. And then we have here, we have direction. Okay, we don't touch that yet. Then we have here pulses, and now I would like to put a diode there. Let's disconnect the power. Here we have a common ground, goes into here. Okay. We probably could run this with just doing like this. Let's see. Yeah. But this is not very well. Well, it turns that way. Okay, okay. But we can do better than that. Let's put 5 Hertz first. Well, it doesn't want to. Well, it does. It moves. Okay, let's put a little bit more speed into it. Okay, let's take a little bit more. Okay. Well, actually now let's talk about how fast you can drive a stepper motor. Wow! Switching off the signal. Okay. And then when you put it back, it starts running right away. Okay. But if you have a lot of speed here, like this, you can accelerate it, but if you stop it now, oh, yeah, what happens, this is just humming in one place, it doesn't turn at all. This is like too high frequency. we have to lower the frequency in order it to operate correctly. And that's the maximum we can use. It's 2.6 kilohertz input, and now it starts running every time I put here. And it will also turn the direction automatically. Should. Yes, it does. But if I have too high frequency here, like this, now it seems to run okay, but when you turn it around or stop it somehow, sometimes it starts, sometimes not. It's very unpredictable. Actually, that's the maximum we can use, and it's that. You shouldn't be running it faster than this one if you want to avoid, and this was the... This also seems to have a delay in it. Yeah. Huh, nice. So now it works effortlessly. Okay. So that's the driver, and that's one type of stepper motor with 4 wires in it. That was probably the easiest one we had. Okay, first motor done. Here is our next candidate. It's a motor like this. Well, if you count the wires, 5. Okay. In this diagram we have one that is like 4, 6 and 8. No 5-wire connection. So how is this, what is up here? Okay, that's actually pretty simple. What we have in this case is a motor that is actually connected like the 6-wire motor, but the center taps are internally connected together, and then they bring these out as one wire. This is because normally when you drive these kind of things you could use that kind of configuration. So we need to find that center tap now. And for this I'm using my ohm meter, and let's see what kind of resistances we have here. Let's take these first. And this is telling 49 ohms. And on the back side here we can read 25 ohms. This means that if we get like 50 ohms, it means that neither of these pins is the center pin. Let's take next. 49 ohms, 49 ohms. Aha! 25 ohms. So these two, one of these is the center pin, but if we measure like the yellow and red, we get 50, so it must be the blue one. Okay. Well, that's just simple logic. So now we should be getting, from each, we should be getting something like 25 ohms. Okay, this is 24 point something. This two, and the last one as well. These are like 330 ohm resistors, like these, and I will put them in series here. Now we have four of these, and I have I don't have the faintest idea how to connect these. Well, let's put them randomly in. Okay, now we have it connected through these resistors, and let's put some indicator tape on that one so that we can see whether it starts turning. Like that. Okay. Wow. Let's see what happens now. If I now power this on, It's vibrating actually. At least we are doing something okay. But it's really weak. It's really weak, and it doesn't act like a stepping motor at all. So what we do now, we exchange two of these. So let's see what happens now. Well, looks a lot better. And it has some force in it. Let's see if we can run this faster. Oh yeah. Now we have figured out this is now the correct. Okay. Again, this one too high frequency. That's the correct one. And this one is really good. It runs on 4.3 kilohertz. But it has smaller steps, as you can see. Let's see if we can turn it around from there. Yeah. And because of the resistors I have here, it doesn't have a lot of force. We have one that is really tiny. And it's this one. Well, this one. And again, we have a bunch of wires which we really don't know what they are, but well, I get rid of this connector first. So this is a 6-wire motor. And now when we look into here, let me show you more precisely. If you look, it has two compartments. So now we already know how these are connected. And now we need to know which one is the middle wire. Okay, it's done. So now we measure the resistance here. Let's see. 155 ohms. So this, if this is 70, we are quite. This green is the middle one. Yeah, 78, and this should give us the same thing. 78. So it looks like the green wires are the middle wires. So let's take this one as well. 79 and 78. So the green wires are the middle wires. Let's power it on. Whoa, whoa. This is running fast. Oh, this is really nice. This guy. Now we have 8 wires, I believe. Well, so how to deal with this kind of situation? Okay, now these are pre-soldered, and well, we have 8 wires. Okay, let's see. We have a black wire here. Then we have a white black. I believe this is one pair. Let's check. Well, let's see if this is one winding. It is 5 ohms. Okay. So following the logic, so black and white black was 1. Okay. Then we have orange and orange white. It's also 1. Okay. This is also. And now none of these should have a connection together. So if we take the black and red, there is no connection. Okay. So they are totally separate. The windings are totally separate. They are coming out like this. So this is a normal 8-wire system where you have like 4 windings inside there, and they are coming out like that. How to connect these? Well, let's just take one. This red one and put this like here. Okay, and then let's pick up the black one. If these windings are on the same side, this motor won't run. But if these are on the separate sides, it will run. Okay. Those we leave unconnected and then we just turn it on. It runs. And it's really powerful. So, what we know now is that these are now on separate sides. Okay. Now we need to find out which one of these is on the same side with the red one. Okay, that will be our next step. So let's take the red and the orange and orange white. Let's see what happens with these. Well, it runs. So these are on the same side with the black. Now the last one we have here, it shouldn't run with this. It doesn't run. Yeah, okay. So now these are on the same side. Let's put these in parallel. Well, let's see if it runs. Oh man, I dropped off. Okay. What you can see is that it's not running at all. So I will reverse the red and red white here, and here I will reverse the black and black white. Now it is. Now it should run. Yep. And should be really powerful. And it is. And it should also go really fast. Yeah. Then we have the next patient. And this is really something. I never tried this one. Okay, let's see which are interconnected. I assume that this might be the case, that red and red white are, yes, this is connected, but this is not. Okay, the white one is not connected here at all. White one is not connected. So red and red white is connected. Okay, then we take the blue and blue white. It's also connected with the white. Yeah, okay. So these three belong together and these three belong. So it's like black, blue and red, white. So let's see. 3.4 ohms. And this one is 3.3 ohms. Looks like the black is the center wire, but let's be sure. Exactly. So we have 6 ohms here between this red and red-white wire, and then we have about 3 ohms to each of these. So this is the center tap, and these are the loose ends of the... I believe the same logic is here. So I take white and that one, so we get 3 ohms, 3.3, so that's the 6. But let's see now. I now connect it. Too fast. That's about the fastest it can do. Oh. This really has very good torque, and I believe when I put like that, it also vibrates a lot. And you cannot stop it with your fingers very easily. So it has the most torque of these all, and it's really powerful motor, this one. was about stepper motors. Hopefully that was somewhat entertaining, and hopefully you did learn something. That would be a miracle, but hopefully that was, well, some information about these things. Especially how to use the driver. It's not that complicated after all. So, in the next episode of FUM0157 machining, if I haven't received my lathe yet, so it will be something else. Maybe I need to do a tiny workbench for myself, because at the moment I don't have anything where I could, for example, hacksaw something. So I probably need to fabricate one. There will be some, probably if I need to do that, there will be some really welding, which is, oh no, okay, so-called welding. But this funny thing will be in the next episode of FUM0157 machining. Till then, keep healthy and see you!